So in this video, I'm looking at the SEC 2017 Junior Cert Higher Level Maths, Paper 2, Question 6. Clara asks all the students in her school some questions about their eating and exercise. One of Clara's questions was as follows. How healthy is your diet? Tick one box. Very healthy, fairly healthy, not very healthy, or unhealthy. She drew a pie chart to show her results. Her results and the size of each angle in the pie chart are shown in the table below. Find the probability that a student chosen at random from this survey ticked very healthy or fairly healthy. Okay, well, we know that 90 degrees as a fraction of 360, a full circle, is 1/4. So the probability of very healthy is, the probability of fairly healthy is 1/4. What about very healthy? That's 96 over 360. So as a fraction, you're simplifying that down as 4 over 15. So probability very healthy is equal to 4 over 15. And if we want the probability of very healthy or fairly healthy, very or fairly, you'd add those two numbers together. So 1/4 plus 4 over 15 is 31 over 60. Next part of the question then. Oh, you could actually also do that, I suppose, by going and adding 96 and 90. You could go 96 plus 90 divided by 360 and finding out what fraction that is. So you'd also get 31 over 60 for that as well. So complete the table above. Note that 90 degrees of a pie chart represents 150 students. So if I know 90 degrees represents 150 students, 1 degree is going to be 150 over 90, and then 96 degrees is going to be 96 times 150 divided by 90. So multiply that by 96. It's 160. So you're going to get 160 students in here. What about these when we know the number of students? Oh, also what's useful, if I know 1/4 of the students is 150, 1/4 represents 150. 1/4 of the students is 150. So multiply everything by 4. 1 full whole of the students is 600. So there's 600 students in total. So to find this number in here, you'd go 600 minus 160 minus 150 minus 170. And you're getting 120 to fit in there. So 120. And we know that 150 represents 90 degrees. 150 represents 90 degrees. So we also need to find out what 120 and 170 are represented by. What are 120 and 170 represented by? One student would be 90 over 150. 170 would be 170 times 90 over 150. That gives 170 is 170 times 102 degrees. And the other one, I can use this piece of information here. We can go 1 was 90 over 150. So 120 is going to be 120 times 90 divided by 150 is 72 degrees. So we got 102 and 72 degrees. We can also check those by 72 degrees, adding all of those together, and you should get 360 degrees because there's 360 degrees in a full circle. So we want to complete the table below to show one question in each case that Clara could ask that would generate each type of data. Each question should be about eating or exercise. One is already filled in for you. So we have Categorical, ordinal data. Well, categorical, to remind you, categorical would be answered with categories, so that is without numbers. Category means without numbers, and ordinal means that there are some order to it. So we could see very healthy, fairly healthy, not very healthy, unhealthy. We could rank them. But categorical nominal would be a question that has answers that are not numbers, so different groups, so answers that are not numbers, and nominal means that they cannot be ordered. So in discussing something like this, you'd be looking at options. Okay, what do you prefer? What, and it can be in relation to what? Can it be in exercise? What do you prefer? Running outside or running on a treadmill? One is not better than the other. Tick one. One is not better than the other, and they are not answered as numbers. Okay. What about this one? Numerical continuous and numerical discrete. As the name sort of suggests, numerical, the answer is going to be numbers. So the numerical continuous one, because it's continuous, you want your answer to sort of fall into a range. Okay, it wouldn't be set numbers. So I think the marking scheme has a brilliant answer for this. How much water do you drink every day? It could be sort of anything. So it's a very wide range. There's a sort of continuous response. It could be 1 litre, it could be 1.1111111 litres. Okay. Another example could be, how far could you run in an hour? You know, that would be a continuous answer as well. Discrete means it wants to be set values. So the marking scheme says how many how many push-ups can you do? Can you do in 30 seconds? Or, like, you want whole numbers or very specific numbers. How many meters? How many full meters can you run in 1 minute? Or it could be, how many burpees can you do in 1 minute? There's no such thing as a half a burpee. Okay, so how many sit-ups can you do in 30 seconds? There's no such thing as half. So you're either going to go for 1 up to a certain number, you know, or 0 even. So then the last question, Clara is worried that the students in her school are not representative, not a representative sample of all the students in Ireland. Explain why it is important to have a representative sample when doing statistical research. Well, you want the data to present evidence that can be generalized for everybody in the population. In your study population. Now, the difference between a study population and a population, the study population, is who you're interested in. It is not the entire population of Ireland. You want your data to be the opposite of biased, is objective. You want your data to be objective. That is, you want your data to be unbiased. marking scheme then for that. You're looking at 15 marks for A and B together. You can pause the video there if you really want to look at that. You're looking at 10 marks for part C and 5 marks for part D. And again, you can pause the video there. Hopefully you found the video useful anyways.